Hi everyone. Continuation on the energies. We saw previously what the kinetic and the gravitational potential energies are. This time let's talk about the spring potential energy. It's a bit of the weirdest for these purposes. Kinetic energy is straightforward. Gravitational potential energy as well. Spring potential energy is a bit weirder, definitely. It's a potential energy, so it is the interaction between different objects in a system that has this potential energy. In this case, it is the objects in what's called a spring mass system. So any situation where you have a spring and a mass, or where the objects you have can be made analogs of springs and masses, will have spring potential energy. So the schematics of it could look like this. You have a wall, the ground, a spring symbolized by this squiggly line, and a mass M. We have, as always, our x and y axis. Every spring has a characteristic that we call the spring constant. Its label is K. Knowing this, the spring potential energy of this system is written like so. USP, for spring potential energy, is 1/2 K d squared. K being the spring constant. Now you're going to ask, well, what is d? D is the displacement from the equilibrium position. Every spring wants to be at rest, much like we all like to be resting, at rest, relaxed. A spring is the same, it wants to be relaxed. If you stretch it in one direction, it will want to contract and come back to equilibrium. If you compress it, it will want to expand and go back to equilibrium. The difference in between the maximum stretch, or the stretch at that time, and the equilibrium position, that is your distance, your displacement, if you wish. So usually we define x is equal to 0 where we have equilibrium. Anything that goes to the right or to the left will be a displacement d. We have the following two cases that we can have. Starting from equilibrium, the spring can be compressed, in which case we will have what we call a negative displacement. The position is to the left of the origin, that is here. Therefore, the displacement, x final minus x initial, is negative. If the spring is stretched, on the contrary, then we will have a positive displacement because the final position is to the right, greater than what x is equal to 0 was. We have, from the starting point, we can either compress or stretch the spring. To find the spring potential energy, you don't care where you were. You just care about where you are with respect to x is equal to 0 to the equilibrium position. Related to that is something that we haven't seen. It's the spring force. So I'll erase this and come back to you in the next one with the spring force.